The Amazon rainforest is shifting into a climate that Earth hasn't seen in millions of years. Scientists looked at decades of real data and had to invent a new word for it: hypertropical. In normal human language, it means hotter droughts that last longer, hit more often, and push the rainforest past its limits. So yes, hypertropical is not a lush jungle, but extra, as you might think. It's more like a tropical forest, but stressed out, overheated, and drying out like a sponge left on a radiator. The researchers behind this say these conditions have no current analog. All this is pretty worrying since the Amazon acts like a giant carbon sink that absorbs carbon dioxide from the atmosphere and stores it in trees and soil. It's like Earth's lungs mixed with a massive storage vault, but when trees get hammered by heat and drought, they struggle to grow. They lose leaves and simply wither. And when it happens, they don't just stop absorbing carbon, they can actually release it back and turn the system into a carbon source, which is the opposite of what we need. Sadly, this isn't a guess based on one bad summer. The team of scientists used data gathered across the Amazon for more than 3 decades. They studied how trees respond when drought hits and temperatures spike, and how the soil behaves too, because soil isn't just dirt. It's a whole living world of roots, microbes, moisture, and nutrients. When drought bakes the ground, trees don't just get thirsty. Their entire support system starts malfunctioning. The Amazon is all about the constant recycling of water. Rain falls, trees drink it. Then they release water vapor back into the air through their leaves. That process is called transpiration, which is basically the forest sweating. That tree sweat helps form clouds and bring more rain. It's like the rainforest runs its own water cycle loop. If drought weakens the trees, the loop weakens too, and then the forest becomes even drier. The last time similar climate conditions existed on our planet was around 10 million years ago. The planet and the animals living on it looked completely different back then, and ecosystems played by different rules. So, for everyone living on Earth now, these conditions are a challenge of a completely new, unknown level. What makes this feel even more intense is how scientists use drought and heat waves as a preview. They looked at how forests behave during extreme events today, because those events can act like a time machine. A quick glimpse at what normal could look like in the next 100 years. That's terrifying because it means today's disaster seasons might be tomorrow's average weather. Like the Amazon doesn't get a bad year anymore. It gets a new baseline. And this isn't just an Amazon problem. The researchers say hypertropical forests will mostly emerge in the Amazon region. But similar conditions could also show up in parts of Africa and Asia too. When forests slip from carbon sinks to carbon sources, things will get ugly fast. It's like a feedback loop, a runaway cycle that feeds itself. The forest stops protecting the atmosphere and starts fueling the problem it used to help control. The Amazon helped keep the atmosphere stable for longer than humans have existed, and now it's getting pushed into conditions it never evolved to handle. It's not the first time, or climate type we'd better never encounter again. When Earth slammed all its land into one megacontinent, it didn't just make a bigger map, but a different planet. Pangean created a monster monsoon system so intense it earned its own name, the Pangean mega monsoon. It was like a normal monsoon blown out of proportion, feeding insane wet seasons in some regions and brutal dryness in others. It happened because one giant continent messed with winds and ocean moisture, like a giant wall in the atmosphere. This climate didn't spread rain evenly, it concentrated it. It created extreme swings, wet months that dump water like a broken fire hydrant, and dry seasons that feel like the planet forgot how to rain at all. The interior regions likely turned harsh and difficult, and coastal zones got slammed with seasonal extremes. Luckily, this climate won't come back the same way because it requires a supercontinent again. But the idea matters because it shows that Earth's climate doesn't just change from temperature, but also from layout. Rearrange continents and the whole sky starts behaving differently. During the Snowball Earth period, the entire planet looked like Antarctica. Ice was stretching almost everywhere, possibly all the way to the equator. Ancient glacial deposits scientists found in places that used to sit near the tropics prove it was real. Here's the terrifying part. Once ice spreads far enough, it starts cheating. Ice reflects sunlight like a giant mirror, so Earth absorbs less heat, cools even more, forms even more ice, and the freeze feeds itself. And when all that ice melted under volcanoes released enough carbon dioxide, it likely did it violently, with extreme weather and huge chemical shifts in the oceans. Then there was the hothouse Earth that felt like the thermostat stuck on broil. There were long periods when global temperatures stayed way warmer than today. Sea levels rose and the planet's climate system behaved like it had too much momentum to slow down. In a hothouse world, the ocean expanded as it warmed, as warm water takes up more space. Ice sheets shrank, and without its natural light mirror, Earth absorbed more heat and dug itself deeper into the hot zone. Warm conditions messed with rainfall patterns and turned some regions into non-stop flood zones, while others dried into permanent drought. We should all be happy the next horrible climate scenario, anoxic events, have not happened for millions of years. But they did happen many times in the past, and may have contributed to mass extinctions. The ocean looked normal from above, but underneath, huge regions turned into low oxygen zones. Part of the ocean became stratified, meaning the layers stopped mixing properly. Warm surface water stayed on top, deeper water got cut off, and oxygen stopped refreshing the depths. Then bacteria took over, breaking down organic matter in ways that created nasty chemical conditions. Whole ecosystems collapsed, and it didn't take a meteor to trigger it. Just the wrong combo of warming, nutrient overload, and messed up ocean circulation. These events also left behind black, organic-rich sediments, like the ocean wrote down the disaster in dark ink. And the creepiest part is that the ocean anoxic events didn't feel like a dramatic explosion. They felt like a slow suffocation of the sea. After you learn about all these, some climate models from the past don't sound that scary after all. The carboniferous Earth looked like it got trapped in wet mode. Giant swamps stretched across continents, and forests soaked the world like a sponge that never dried out. The air carried more oxygen than today, which sounds nice until you remember what oxygen does to insects. This was the era that produced giant creepy crawly legends like millipedes the size of a car. This climate also allowed to building huge coal deposits because withered plants piled up faster than nature could break them down. So the climate didn't just create scary life, but also fuel for the future. Coal formed because the planet had endless swamp forests and the right conditions to bury carbon instead of recycling it. This climate won't come back because Earth's continents, ecosystems, and carbon cycle don't run the same way now. During the early Eocene period, our planet ran warm enough that the poles didn't freeze the way they do now, and the temperature gap between the equator and the Arctic shrank. Scientists call this an equitable climate, which means Earth felt more evenly warm across latitudes. High-latitude land stayed above freezing year-round in some models and evidence. Places near the Arctic were living without deep winter ice dominating everything. It didn't mean the whole world felt like Hawaii, but it did mean fewer extreme contrasts. If the planet warms enough, pole to equator differences can shrink again, and seasons can soften in certain regions. But the Earth system today has ice sheets, ocean patterns, and human-built infrastructure that never existed back then. So if low-season Earth returns, it won't feel calm.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.